Here we're looking at something compounded continuously, so we're going to write down this formula. A equals P e raised to the RT. A is the amount after time. P is the amount of money you put in. R is your interest rate. And T is time in years. So we can pause the video and write down this formula if we need to. We're going to use it on this first problem here. We want to see how long it will take. So what is T going to be to grow 25,000 to 150,000 if our interest rate is 9.3% compounded continuously. So compounded continuously means use this APERT. We want to plug into this and solve for T. We want to figure out, is 25,000 the amount of money we're putting in or the amount after time? Well, we want to put in 25,000 and have it grow to be 150,000. So the amount after time that we want is 150,000. The amount that we're plugging in is 25,000 times e to, this is the interest rate, but we always need to change it to a decimal. So we're going to take this 9.3% and divide by 100. We're really plugging in e to the 0.093 times t. Now we need to solve for t up in the exponent, so start by dividing by 25,000 on both sides, which will give you 6. I'm going to leave some space. We have e to the 0.093t. Now to bring that t down, we're going to take ln of both sides. That way we have 0.093t equals ln of 6. And lastly, we'll divide both sides by 0.093 to figure out how many years it takes to get 6 times the amount of money. We're going from 25,000 to 150,000. I'm going to plug into my calculator ln of 6 divided by 0.093 and round to the nearest tenth of a year. So t, it's going to take about 19.3 years. 19 years approximately to get from 25,000 to 150,000 if we can grow it at a rate of 9.3%. We're going to end up with 6 times the amount of money if it's compounded continuously. So every time you see compounded continuously, you're thinking APERT. A equals P e raised to the RT.